In this video, we are going to discuss about the most economical or most efficient triangular channel section. As you can see in this figure, this is a triangular channel section where y is the depth of the flow and theta is the angle made by each side of this channel section with the vertical. So now let us find out what is the condition for building or for the construction of a efficient triangular channel section. Okay, of course you have remembered, I hope you remembered that in case of rectangular section, if the depth is y and width is b, uh, y is equals to b by 2. Okay, if y equals to b by 2, then this section is an economical section. So, what is the use of this condition actually? So, when you make a channel section as economical, it it costs less. Okay, less amount of money is required. So we know this is the condition for rectangle, and of course in the circular section we have theta 308 degrees for maximum discharge and 257.5 for maximum velocity. And in the trapezoidal section also we have that, right? The side slope has to be 1 by root 3, and the top width has to be 2 times of the slant length. So these conditions help us to build an economical channel sections. So coming to this channel section, the first thing we have to do is to write the condition. What is the condition? dp by d theta equals to 0 for getting the condition for economical triangular section. Okay. So now you need to know what is A and what is P. From this equation figure, you can write this is as O and this is A, this is B and this is C. So this is Y, right? OB is Y. So what happens to the top BC? BC ఏమవుతుంది అంటే, see, let me write here. Apply tan principle. Tan theta is equals to BC by OB. What is BC? The unknown which I need to find out, and OB is Y. So BC is equals to Y tan theta. So this is Y tan theta, and AB is also going to be Y tan theta. So what is the total top width? 2Y tan theta. Okay, so let us find out the area. What is the area? Area of this triangle is half into Y into Y tan theta. And similarly, this left side triangle also has the same area, half into y tan theta. So two triangles, so 2 into 1 by 2 into y tan theta. What do you get? 2 to get cancelled and y square tan theta. And now P. Okay, P is equals to AO plus OC. So what is that going to be? Okay, let us find out this. See, AB is equals to y tan theta and BO equals to y, right angle triangle, right? So OA is going to be root over y square plus y square tan theta, tan square theta. So take y common, so you get 1 plus tan square theta. So now from this you can write OC is also equals to y root over 1 plus tan square theta. So finally I am going to write 2 into y root over 1 plus tan square theta. But from identity principle, from trigonometric equation identities, okay, there are 3 identities and one of them is secant square theta minus tan square theta equals to 1. Okay, so what happens to secant square theta? 1 minus tan square theta. So secant theta equals to 1 minus tan square theta to the root. Therefore, here I can substitute that formula. So I can write P equals to 2 by secant theta. Okay. But here, as you can see, this area equals to y square tan theta. I can further simplify this as y equals to, or y square equals to a by tan theta, that equals to y equals to a by tan theta. So putting that here, I get P is equals to root over a by root tan theta into secant theta. So now we have the equation for P. So in order to get the condition, what I have to do is just differentiate the vector perimeter with theta and equate it to 0. Okay, so let us continue here. So you can use now principle dp by d theta equals to 0. D by d theta into 2 root over a by tan theta secant theta equals to 0. And therefore, 2 into root a comes out, d by d theta of 1 by tan theta, of course it is in root, so secant theta equals to 0. See here, here the equation gets further simplified as this: secant theta by root over tan theta equals to 0. So now this is as u by v. You know what is u by v? This is u dash v minus u v dash by v square. So what is u here? U is equals to secant theta. So u dash is equals to, what is this? Okay, secant theta tan theta. So derivative of secant theta is secant theta tan theta. Okay, and v is equals to root over tan theta. So what happens to v dash? V dash is equals to, this is like root x, right? So root x ki formula ante 1 by 2 root x. So root tan theta ki 1 by 2 root tan theta. But root లో x కి బదులుగా ఏముంది, tan theta ఉంది, theta కి బదులుగా, రైట్? సో ఇప్పుడు మళ్ళీ theta tan theta కి మళ్ళీ డెరివేటివ్ చేయాలి. tan theta కి డెరివేటివ్ ఏంటి? secant square theta. Okay, so we have to substitute these in here. What do we get here? Okay, let me write down the equation here for you. D by d theta of secant theta by root over tan theta will be equals to, what happens to this equation here? U dash. What is u dash? Secant theta tan theta. Now v. What is v? Tan theta. So root over tan theta. Okay, next minus u. What is u? Secant theta. Next into v dash. What is v dash? Secant square theta by tan theta. This is under root and this is 2, and this has to be equals to 0. Okay, let me write this equation a bit again. Let's just write it again for your reference to make it easier for you to understand here on the screen. So there's finally dp by d theta equals to 0. That implies what we got here is d by d theta of secant theta by root over tan theta equals to 0. So this equation has become secant theta tan theta into tan theta అంటే ఇది u dash ఇది v మైనస్ ఇంకేముంది secant theta అంటే divided by root over tan theta into 2 into secant square theta. So this is the equation we got here. See, secant theta tan theta into root over tan theta minus secant theta into secant square theta by 2 root tan theta, that equals to 0. Okay, so now just simplify this equation further. Okay, equals to 0. So what can you do is you can just take out this secant theta, and what else can you take? Yes, you can write this as tan theta, right? This is tan theta. Of course, you are going to have here v square, but this v square will go on to this side, so becomes 0. So whatever it is remaining, write it down here. Okay, tan theta into root over tan theta minus secant square theta divided by 2 root tan theta equals to 0. Now take LCM. Okay, what happens to LCM? 2 root tan theta into tan theta minus secant square theta divided by 2 root tan theta, that equals to 0. Of course, this goes on to this side, becomes 0 again. So what happens is root tan theta here, root tan theta, so tan theta. Again we have another tan theta, so 2 tan square theta minus secant square theta equals to 0. So you get 2 into sin square theta by cos square theta minus 1 by cos square theta, that equals to 0. See here, you can take this cos theta as common and send it to the other side, and then you are going to get the following equation, that is 2 sin square theta minus 1 equals to 0. So sin square theta, of course 2 into sin square theta equals to 1, and sin square theta equals to 1 by 2, and sin theta is equals to root over 1 by 2, that is 1 by root 2. So now what happens to theta? Theta is equals to sin inverse of 1 by root 2. So you can guess, right? Theta equals to 45. Therefore, for a triangular channel to be economical, the theta should be 45 degrees. That is, the angle between these two inclined sides has to be 90 degrees. Okay, so this is the condition for this channel. Okay, and of course you can write this in this term. See, top width. What is the top width of the triangular channel? Top width, you know, this is y tan theta and this is y tan theta. So use this principle here. Okay, so what is this? Top width is equals to 2y tan theta. So it is equals to 2y tan 45. So that is equals to 2y. So you can say that the top width has to be 2 times of y for a triangular section. So when the top width of the channel section flow is twice the depth, then the flow is economical. The channel section is economical. Okay, you have to design in such a way. So in order to get the top width as 2 times of depth, the angle should be 90 degrees, right? This angle should be 90 degrees. So this is the condition for triangular section. Okay, in the next video we are going to see about specific energy concepts. Okay, thank you.